Welcome to Derivatives Applied Part 2. All right, example number 1, a voltage V equals T raised to the third power plus 1,000 volts appears across a parallel RC combination where R is equal to 300 K ohms and C is equal to 20 microfarads. Find the resulting current IG at any time T. So we've got the Kirchhoff formula. IG is equal to C dV dt plus V over R. And we can see in this equation C over dV dt, if we remember from the last section, is equal to the current through the capacitor. So that's a current plus V over R. We know Ohm's law, that's a current. So think Kirchhoff's parallel law, currents, any two currents at a node add. Okay, so we're adding two currents together. Okay, we've got C is equal to 20 microfarads. We put that in the formula, and R is equal to 300 K ohms. Now, we want to find the derivative of the voltage so that we can multiply it by the 20 microfarads. So that's equal to 3T squared. Put that into the formula now. And we also need to put the original V divided by the R into the formula. That's the T raised to the third power plus 1,000. And the question is asking for the current at any time. So we just want to get the formula in terms of current and time. And so you can see we've got IG, or the generator current, if you would, is equal to T to the third power divided by 300 times 10 to the 3 plus 60T squared divided by 1 times 10 to the 6 plus 1/3, and the unit will be in amps. Okay, example number 2. Now we're going to do Kirchhoff's voltage law, and we're going to find VG using the current. So we've got a current, I is equal to 3T raised to the third power plus 2 amps. Flows through a series RL circuit when R is equal to 100 ohms and L is equal to 20 henries. Find the voltage across the circuit when T is equal to 0.125 seconds. So we've got a formula. This is a Kirchhoff voltage law. We remember from before that L di dt was equal to the induced voltage, and we know that R times I, Ohm's law, is equal to volts also. So we're just thinking of a simple series circuit. Voltage plus voltage equals the total voltage, the generator voltage, VG. So if we start substituting in our knowns, we've got 20 henries times di dt times 100 ohms times the current that was given. Di dt is equal to T raised to the -2 over third powers. Put that into the formula. And then we solve the formula in terms of T. And now we can put in our 0.125 seconds and solve for VG equal to 430 volts. Okay, example number 3, the series circuit consists of a 22 Henry inductor and a 68 ohm resistor. The given current is I is equal to 2T squared plus T, and the question wants to know after what time does the voltage across the combination, which would be the VG, equal 375 volts. So we've got our VG formula from before, and we can put the 375 volts in for VG, drop in. We know that we've got a 22 Henry inductor and a 68 ohm resistor, and that I is equal to 2T squared plus T. I take the derivative of that, put that in, multiply that into the 22 henries, and then solve it in terms of T. Now, this equation has a T squared in it, so as soon as you see the T squared and the T, set everything equal to 0, and you end up with the 136T squared plus 156T minus 353. So we should be able to spot that and say, okay, we can use the quadratic equation to solve for t. And we get 2 t's whenever we use the quadratic equation. We've got a t equal to 1.137 seconds or a t equal to minus 2.284 seconds. And we know that there's no such thing as negative time, so our final answer is t equals 1.137 seconds.